Alright, so we're going to go into 6.1 part 1 here, applications of quadratic functions. So one of the most common applications of quadratic functions is projectile motion. When objects are thrown or shot through the air, we can model them with parabolas. These functions are often named h of t, so the height of a function, height is a function of time, even if an object is shot straight up into the air. Its graph will still appear to move forward, since time is always moving forward. Every object in projectile motion has the same force acting upon it, gravity, so we will notice similarities in each of these functions. A leading coefficient of -16 in feet, or they could put it in -4.9, which is in meters. So let's look at a problem here. So a water balloon is launched straight up. The balloon's flight is modeled by the function of h of t equals -16t squared plus 192t, where h of t is the height in feet after t seconds. Answer the following questions graphically and algebraically. So we'll start with algebraically set up here. So what is the height when the water balloon, what height did the water balloon start? So in other words, where to start? Well, we want to put in our time of 0, right? So with this one, in this case, our time is 0. So say time is equal to 0. So if h of 0, so we're going to substitute every t value of the 0. So -16 times 0 squared plus 192 times 0. Well, hopefully you all see that that is 0 plus 0, which gives us 0. So the height that the water balloon started at is at 0 feet. Alright, so now, when did it reach its maximum height? So when did it get the highest? So with this one, we can do our little equation here to where we found out, take -b over 2a. Okay, in which case our a value is -16 and our b value is 192. So with this, we're simply going to say that we have a negative, our b value is 192, and we have a 2 times our a, which is -16. So we should get -192 over a -32, and if we do the math on that, it should give us a 6. So since we're talking about t is in seconds here, we're going to say it reached our maximum height at 6 seconds. Okay, so what was its maximum height? So what was the maximum height that we actually went to? Well, if we know we reached our maximum height at 6 seconds, well, then let's just put in, let's set up that for t equals 6. Okay, so in this case, t is equal to 6. So with that, we're simply going to say h of 6, and we're going to go replace every t value with a 6. So -16 times 6 squared plus 192 times 6. And with that, calculating that out, you should get 576. In this case, we're talking about our height is in feet. So the maximum height after 6 seconds was 576 feet. Okay. And so when did it hit the ground? So in other words, we want to know when our height was at 0, right? So we want to know overall when our h So t equals 0. So we're going to take this equation here, and we can simply write out here, I'm going to write it here on this side, say 0 equals negative 16 t squared plus 192 t. This equation probably looks a little familiar, and we're solving these quadratic equations. So with this, let's go ahead and factor out. So if we factor out, it looks like we can take a t out for sure, because we have t squared and a t. And then the 16 is also going to go into that 192. So we can factor out, let's go ahead and factor out the negative 16, just to get that negative off there as well. So let's take that out. So we can simply say this is 0 equals negative 16t. We can factor out. And with that, we should get a t, because negative 16t times t is just negative 16t squared. Okay. And then we'll say minus, because we want to have a plus 192, so negative has a negative, we do plus. So minus, and then 192 divided by 16 is 12. Alright, so now, as we've done in the past, we're going to set both of these equal to 0. So we'll take this one, we'll say negative 16t is equal to 0. And we'll take this one, I'll say t minus 12 equals 0. So in this case, if we divide by negative 16 on both sides here, we should get t is equal to 0. And then if we add 12 to both sides over here, 12 away, and we're left with t is equal to 12. Alright, so we know it was at the ground at time equals 0. However, the overall value that it took, or time that it took to get back down to the ground, is our 12 seconds here. So with that, we're going to simply say we have our 12 seconds. Alright, so doing the same problem here, what was the height at 9 seconds? So again, we're just substituting in h. Instead of a t, we're at 9, alright? Because our t is equal to 9 seconds. So we're going to substitute this in. So we have negative 16 times 9 squared plus 192 times 9. And when you crunch those numbers, you should come up with 432 feet. Alright, now one other thing with this problem. So looking at its graph and considering the real world context of the problem, we want to select the appropriate domain. So domain is dealing with your x-axis. Range is dealing with your y-axis. So we're going to be looking at our x right here, okay, and our y is our range. But we're going to be dealing with our x-axis for our domain. So again, that's our domain. So what we want to look at is how far left does it go on the x-axis when it crosses, and how far right does it go on the x-axis to cross. So it looks like right here we have our farthest left point is at 0, and then our farthest right point when it crosses the x-axis again is at 12. So our domain should be anywhere from, and since it's on a line, it'd be less than or equal to or greater than equal to. In this case, we say 0 less than or equal to t, which is less than or equal to 12. In other words, from 0 to 12 seconds, we had our balloon taking flight. So C is our answer. So now let's look at this graphically. So what height did the water balloon start? Well, of course, hopefully you guys can see which case it started at. Right here we set it at 0, right? So it's 0 feet. And when did it reach its maximum height? Well, we're going to look here, the line of symmetry. When it meets the line of symmetry, when it peaks, and of course our x value is in seconds, and our y value is in height. So after 6 seconds, we reached our maximum height of 576. So maximum height was maximum time when it reached its height. Maximum height is 6 seconds. And I just said, what is maximum height? The maximum height it reached was 576, just by looking at the graph. And then when did it hit the ground? In other words, how many seconds did it take for it to hit the ground again? So, and as we calculated algebraically, we saw it took 12 seconds. Okay, let's look at some more data here. So again, below are some common questions we will come across. So for these types of problems, at what height did the object start? So with that, when you're trying to figure that out, always set t equal to 0. The time that it starts is 0. Then we got when did it reach its maximum height? So therefore, we're going to find the line of symmetry. Okay? Find the line of symmetry. At what was its maximum height? In which case, you can look for the vertex, right? The vertex is when it reached its peak, okay? So in other words, like when it hit that line of symmetry is that peak point, right? That's the vertex of it. So the vertex, again, this dot right here on this graph was the vertex. Right there at 6 seconds. Okay, and when did it hit the ground? Well, with that, we're going to set the h of t is the height of whatever time value they got. We're going to set that equal to 0. Set that equal to 0 for your height, and you should be able to find how many seconds it took to get there. All right, so this one, we're going to take a ball and throw it off the top of the building. Its flight is modeled by the function h of t equals negative 16t squared plus 96t plus 112, where h of t is the height in feet after t seconds. So we're going to answer these following questions here. So we're looking at this. How tall is the building? Well, therefore, we want to know where it started from, right? The start, which we talked about, making t equal to 0. So in this case, we're going to make t equal to 0. And if we do that, so h of 0, we say negative 16 times 0 squared plus 96 times 0 plus 112, well, that's going to give us 0 plus 0 plus 112. So overall, we should get 112. So 112 feet. Don't forget to put what context we're talking about here. Your feet, right? So we're talking about feet. Alright, so now we're saying when did it reach its maximum height? So we're going to use that for our line of symmetry here equation. That vertex is a negative b over 2a. And again, our a value is going to be negative 16. Let's go ahead and write this different color so we can keep an eye on it a little bit. So a equals negative 16. B equals 96, and C equals 112. Okay, so now we got our negative B, so we should have a negative 96 over 2 times a, which is negative 16. So we'll get negative 96 divided by negative 32, and that gives us 3. So it reaches maximum height at 3 seconds. Okay. And so what is maximum height? Well, if we know it takes 3 seconds, then we're going to take our t is equal to 3, so h of 3, and we're going to put that in our equation. So negative 16 times 3 squared plus 96 times 3 plus 112. And with that, we should get 256. So we're looking at 256 feet. Okay, so this is maximum height. And when did it hit the ground? So on this one, we want h of t to equal 0. And to do that, let's go ahead and write this over here. And we're going to say 0 equals negative 16 t squared plus 96 t plus 112. And we want to find our values of t. So with this, let's see what we can do here. Now, with looking at these numbers, just by looking at them, it looks like 16 can come out of each one of these. So let's go ahead and factor out a negative 16 to get that negative off of our a value up there. So we're going to say 0 equals negative 16 times, and in this case, that will give us a t squared minus, and we should get 6t, and then minus, we're going to get a 7. And now we can factor out the t squared minus 6t minus 7. And to do that easily, remember we can always use our big X. Because now the a values in this problem for that one is a is equal to 1, b is negative 6, and c is negative 7. So we do our big X. A times c up top, right? And our b value down here. We're going to take here on the side, we're going to write a t here, because we know this t is our variable. So a times c, 1 times negative 7 is negative 7, and our b value is negative 6. So these two values, we've got to multiply to get negative 7, but add up to give you negative 6. Well, I'm pretty sure we can take, to get a 7, you got to take a 1 and a 7, and add them up to get a negative 6, we'll take a negative 7. Because positive 1 minus 7 will give you negative 6, and 1 times the negative 7 will give you negative 7. And then you go bottoms up and write those out. So now, since we have those values, we can take the 0 is equal to negative 16 times t plus 1 times t minus 7. Okay, and so now we can take these all and set them equal to 0. Well, we take this guy and we say t plus 1 equals 0. Take this one and say t minus 7 equals 0. We should get t is equal to negative 1, and t is equal to 7. Well, we know we can't have a negative value for time. We're not going to go back in time, so that one's out the window right there. So we should get our t is equal to 7. So after 7 seconds is when our ball fell from the top of the building and hit the ground. So 7 seconds. Try to write seconds better. 7 seconds. Alright, so now let's do one more question here for this problem algebraically. So looking at this graph, what is the appropriate domain? So according to this, remember we started out at 112 for our height, Okay, but that's not where we cross the x-axis at. So following this, we cross the x-axis, the farthest left we go is -1. -1. And the farthest right we go, we hit 0 again, right? For our height, for our y value of 0. So we cross that x-axis at the value of 7. So we should be going between -1 and 7. So we should have the value of dealing with this for being appropriate domain, you would think it would be -1 to 7. However, though, for the actual value in the real world context, because we can't have a negative value for time, right? So for this actual problem, the value you want to use is where you start at for your time is 0. Right? So we want to start at 0 because our time. You can't have negative time. You can't go back in time. So because this is the problem that you're using real world wise, you're always going to start at 0. So we're going to go from 0 to 7. So 0 less than or equal to t less than or equal to 7. So we should get with a d value on this one. Okay. Alright, so now let's look at this. So this one, how tall is the building? Well, we did that off the first calculation. We saw that initially where we started at, how tall, is 112. It's 112 feet. When did it reach its maximum height? Our calculations, and according to this graph even, you can see after 3 seconds, it reached 200. Oh, I'm sorry. When did it reach? At 3 seconds. And then what is its maximum height? At that 3 seconds, we saw it reach 256 feet. And then when did it hit the ground? Well, we saw after 7 seconds, according to our calculations, as well, it hit the ground. And according to the graph, after 7 seconds, it's back down to 0 again. It crosses that x-axis. So it hit the ground at 7 seconds. Alright, so hopefully that helps a little bit of the applications with quadratic functions. And you got some big ideas with that and figured out how to work those out. I'll see you next time.